this video we look at displacement time graphs and velocity time graphs. We will make use of the Subat formulae. Displacement time graphs. On a displacement time graph, displacement can be positive or negative, but time is always a positive value. Anything horizontal on the graph represents an object that is stationary, and then you've got positive gradient and you've got negative gradient representing positive velocity and negative velocity. This displacement time graph shows an object which is stationary for 5 seconds with a displacement of 8 meters. So on this diagram, this person is stationary at A with a displacement of 8 meters for 5 seconds. With a constant velocity, the person moves from A to O, taking 2 seconds. The displacement at O is 0 meters. The gradient of this portion of the graph, which represents velocity, is -4. So the velocity is -4 meters per second. The person continues to move from O to B with the same constant velocity. At B, the displacement is now -4 meters. So the gradient remains the same because the velocity from A to O, O to B does not change. We're looking for the value of t, time, at this point here. We know the gradient in this region already. Because it's the same straight line, the gradient here, and hence the velocity, will also be the same. So we can write down a simple equation for the gradient, and if we solve this equation, we get t is equal to 8 seconds, which is the value here. In this example, somebody starts walking along this path and they end at this point. So this is the distance travelled, but the displacement is the length of this direct route from start to end. The journey takes 20 seconds. Using the distance, we can calculate the speed, and using displacement, we can calculate the velocity, like this. Velocity is displacement over time, and speed is distance over time. In this example, we want to work out the displacement A to C. It's a simple problem using trigonometry in a triangle. Applying the cosine rule gives us AC, the displacement, 8.63 meters. Velocity time graphs. The gradient this time will represent acceleration. In this graph, the gradient of the graph represents acceleration, and then where the graph is horizontal, we have constant velocity. Here, the velocity in this region is 8 meters per second, and it's not changing. So an object continues to move with the same constant velocity. And then we have deceleration or negative acceleration until the object comes to a stop. And we've got various times here. T is 0, T is 4 seconds, 10 seconds, and 15 seconds. Another interesting feature of this graph is that if you calculate the area under the graph, so the area in this region will represent the distance travelled. The area in this region, the rectangular part, represents the distance travelled here. And likewise, this region represents the distance travelled here. So the total distance travelled, so the triangle, the rectangle, and the triangle here is 84 meters. Now, because this region has a 0 gradient, then the acceleration here is 0. We have constant velocity. But we need to calculate the acceleration in this region and this region. So the acceleration here is 2 meters per second squared, and the acceleration here is negative because the gradient is negative. It's minus 1.6 meters per second squared. We can also say this as the deceleration is 1.6 meters per second squared. Do you notice the difference in signs here? A negative acceleration is the same as a positive deceleration. Here we're trying to work out the total distance travelled by an object, and the total distance travelled is just the sum of all of these areas. So all 4 of these triangles, if we calculate the area of each one, add them together, that will give us the total distance, not displacement, but the total distance travelled, which is 48 meters. Now, displacement is slightly different to the distance travelled. For displacement, we take the area which is above the horizontal axis, so the area of this region, and from that we subtract the area which is below our horizontal axis. Okay, so it's the yellow minus the green area, so 8 meters. The initial acceleration, the acceleration here, the gradient of the graph here, is 4 meters per second squared. We just need some coordinates. Change in y divided by the change in x gives the gradient, which is the acceleration. And the acceleration after 12 seconds, so that's 10, and we have 15 seconds here. So after 12 seconds, it's just the gradient there, which is the gradient of this line. 1 meter per second squared. More examples to follow in the next video.